welcome back to the Lennon Stand. I'm Lennon, and today we're going to be doing an experiment. Our experiment today is going to be answering the question of what is sound? Sound is something that we take quite a bit for granted. I'm using it now to be able to convey an understanding to you through the microphone, creating from my mouth. But we can't really see it in most circumstances, unless we have some very special equipment. And luckily, I'm here today in Discovery at the music area. And over at the music area, we have a very special vibrating tube. Inside this tube is a speaker on one side that's going to be producing our noises. And then in here, we have little polystyrene balls that are very, very small, and they should move around depending on the movement of the air. So I'm going to press this button in a moment, and we're going to see our polystyrene balls move around depending on the sound that's coming. So 3, 2, 1. Oh, perfect. So we can see here that it's very gentle sloping up into quite a pronounced vibration here in the middle, and it moves all the way down. Now, this vibration is actually dependent on the frequency of the sound wave that we hear. That if I increase the frequency, and it makes a bit more of an annoying noise, we can see even more waves breaking into it this time. And we can also see from the side, it almost looks a little bit like a beach wave that we'd see. Alright, beautiful. So this answers the question of what we can really describe the vibrations in air to be. Now we're going to draw that on the board so we can sort of see it. So we had a whole bunch of little dots along. They seem to be evenly spaced in the middle, but as we got outer, the balls got a lot less pronounced and they had a lot less energy in it. So this little space here in the air is actually our rare fraction. So this is where all the balls are being pushed away from one another from all the air being forced inside this area. This little bit here actually represents the wavelength. So that is the length of our sound wave in this little space here. So this really answers what sound can be and how we can see it in air. But if sound is just simply vibrations in air, maybe then there's a couple different objects that we can put our vibrations into and see if they make some sound. Now, there's been a very conveniently placed coat hanger behind me, and I have a little bit of dental floss. Now, this experiment isn't going to be necessarily something that we'll be able to hear here at home, but I absolutely invite each and every one of you viewing here today to look like a dork as we hold our coat hanger between our dental floss. We'll put our dental floss up to our ear and we'll drop it on the ground. We'll see if we can't do that at home. So we hold it up to our ears and we'll hit it against something metal so we can hear the vibrations within our coat hanger. So, as in each and every time I hit this, it vibrates through our coat hanger, sort of sounding quite a lot like church bells, and it vibrates up our string into my ears so I'm able to hear it. So that's an experiment I absolutely invite everyone at home to do, because you couldn't necessarily hear anything, but I could hear the beautiful church bells. Now, here's a different experiment that we'll be able to see more at home. Over here, I have a speaker inside a bowl of water. Now, the speaker itself, when we turn it on, we're going to force the sound from the speaker into the water around it. And we should be able to see the vibrating water. So I'm going to press the play button. That's a little bit embarrassing. Let me go on to the next song. Now, we can see it's not vibrating too much, but if we go along a bit more into the song, we can see that the speaker really sparks up full of energy as the sound of the music vibrates throughout the water. And it seems to have a little bit of the pattern from the way it disperses through it. With a deeper noise, affects the music a lot more. The deeper sound, the lower the frequency, but the higher the sound seems to not really be able to affect the music as much. But around it, it really creates a beautiful little wave-like pattern that depends on the sound that's being produced. Now this is an experiment that can be done at home. Either we put a speaker under a big bowl of water and then we'll be able to vibrate it, or if we're lucky enough to have some waterproof speakers, we can do that exactly how I did just there at home as well. It's a lot of fun and it looks better with your own eyes, so I absolutely entertain the idea of it. Now, I am going to use my Sharpie that I dropped on the ground to draw exactly what we saw before. So we have our speaker here in the middle, and it was making different noises on the outside of it. So we can draw it a little bit, and these really depended on how much and how deep the music was. Now my drawing's not the best, but lucky I'm a scientist and not an artist. So I hope that all of us at home will be able to make a much more beautiful picture than my sun that I have here. I'll draw some cool glasses on our sun, because everyone knows how cool the sun is. So, now we move in to the last little experiment of the day, that we saw vibrations with our own eyes through water, and we saw me hitting church bells through the coat hanger against the wall. Now we're going to see what happens when we turn up the volume so much more that the air becomes a lot more compressed, making something quite amazing. So to do this, we're going to move over to these three instruments that I have here today. First, we're going to show you how you can make your own one at home. I have here a cup that has a hole in the bottom with a balloon that's been cut in half. And simply, we're going to make a gun that's going to shoot air. Sort of just like a really big sound, maybe like an explosive sound. So, we can't really see exactly what's being shot unless I pull out my hair. We'll be able to see my hair move as we shoot it. So, I've pulled out my hair and I bring my cup all the way out and I shoot it across my head, and we can see that all the air explosively is fired out the end of our cup, forced to the little hole, and it creates quite an impulse of air, and also a large sound from the rubber band hitting the cup. Now, we couldn't actually see the air there as, well, we can't see air. So instead, we're going to take to something a bit thicker than air, smoke. And we're going to fill in this large one full of smoke. And now, if we shoot it, we can see the smoke gets fired at the end of it, almost creating a really beautiful shape of a ring. Now, because here at Discovery, we love to up the ante and go as big as we possibly can, we have an even bigger cannon here, where we have our little balloon on the end, and instead of pulling it back, I'm just going to smack it as hard as I can with my hand. So just like before, I'm going to bring our smoke machine over to our cannon, and we're going to fill it up with smoke. So we're shooting something out of it rather than just air. Now that it's nice full of smoke, we're going to move everything a bit out of the way so we can get some really nice camera shots. And I'm going to stand behind it and hit the air cannon as hard as I possibly can. And we'll see massive gusts of air and smoke plume out the end of our hole here. And once again, I was making an even louder noise that time as I was hitting the very end of it. So we saw what happens when something is a bit more explosive. Usually, just like before, we have all of our little dots formed into one super compressed little area, creating a massive explosive barrier, making a massive noise. Or, if we have our explosion funnel through a little tube, it can create a donut-like shape that we call a torus, which is just literally a donut. And the reason it makes a beautiful donut is from the way the air wraps around our tube here. So, today we've got a little bit off track from describing what sound is, but we've instead started describing how sound affects the air movement as it travels, and how sound, we're actually able to hear the sound with our own ears. So, this then concludes our Lennon Stand show today. I hope we've all had a brilliant time answering our question and doing a couple experiments to find out what is sound. And I hope to see you all next week, tuning in for another episode of the Lennon Stand. If you have any questions, feel free to leave them in the comments section below. Remember to like and share, and I hope to see you all next week. Thank you very much.